ports for the mounting.
Recording is on.
On the top, and this hole here is for the potentiometer that is on the PCB here. So like so. So that's essentially what we're trying to achieve today. So let's get started. I'll start off with a new file, and I'll keep going between the original file and the one that we are doing today, so I can show you what we're trying to achieve at each step. So let's get this. So this is going to be our first step. We build the basic structure for the base that will eventually turn out to be the bottom part of the PCB. And to get here, you need to have, let me show you. This, which is essentially the PCB and all of its component and mounting holes. So you can use these references to figure out your actual case design. There's a couple of other. So these are the essential things. We need the PCB with its holes and mounting holes and stuff like that. We need the USB connector, the potentiometer, and the 3-pin header for the Morse keys. So let's look at how to get these first before we even start making the case layout. So with the new file opened up in KiCad Step-Up Tools workbench, you'll notice there's an icon that says load the KiCad PCB board and parts. So that's how we start off with. This is nice because you don't have to worry about exporting from KiCad as a step file. Step-Up Tools manages that for you. You can straight away open a .KiCad PCB file like so. So clicked on the file I want to use, click on open, takes a while for it to import everything, gets the board, gets all the parts, puts them at the locations, and then gives a report if everything's okay or not. Tells the number of parts placed and stuff like that. PCB dimensions. So here's where we are at. If you notice the tree, you'll notice there is one group called Morse key that has been imported now. And if you expand that, there are two subgroups in it, both geometries and step models. Step model is obviously each of the step model for all of the various parts. So here's the capacitor. I can hide it by pressing the space bar. So let's hide the capacitor. Here's the 80 tiny. I can hide that by pressing the space bar and so on. So these are the step models for the various parts. And in both geometries, you'll notice the PCB, which is this purple board that you see over here. That's your PCB. And you'll notice just below the PCB is a hidden element called Pcb Sketch. That's the interesting one. That's the one that is useful. If I hide the PCB and unhide the sketch and unhide all of these step models as well, you get the outline of the board. And if you double click this, you enter the Sketcher workbench in FreeCAD, and this lets you constrain this sketch if you want to. But for today, because we also need to know the location of the USB connector and the potentiometer and the other mounting holes and stuff like that, just the board outline isn't really going to be useful for us. So I'm going to close this because we don't need the sketch. It's not useful for us today. And I'll unhide the PCB, and I'll unhide the parts that I want to use. So let me first of all close these things that need closing. Hide all of these. Then see if I can unhide the one. I've hit a snag over here with the version that I'm using. Okay, let me try that again. Open up Morse key. Opens up as a new file, as you can see. So let me first grab the whole Morse key file and drop it into unnamed, the one that I'm trying to work with. There it goes. I can now close Morse key because I don't need it. And I can hide the parts that I don't need. Don't need the capacitor, don't need the IC, don't need the speaker, don't need this Morse key header, don't need the other capacitor, don't need any of the resistors or diodes. I need this. So here are the three parts: the header, potentiometer, the USB connector, and the PCB. So we are going to create an outline that gives us these elements as sketches. Actually, we can also just hide the USB and the header pins because we don't really need those at the moment. All we need to know is the center of this screw for the potentiometer. That's why we need this component visible. So I have this and I have the PCB. I select these two items. You can use control to have multiple selections. So click on the PCB to select it. I click on R4 to select it by pressing the control key. And then I'm going to go to the draft workbench. That lets me use this icon which says create shape 2D views of selected objects. What it's going to do is project the top view of whatever is visible here as a two-dimensional sketch. So let's try that. Once I click that, I have these shape 2D view items over here. I can now hide the whole Morse key project and we hide the grid. So here, this is a two-dimensional representation of the board layout with its mounting holes, component holes, and the potentiometer. And we are going to use this as a starting point for creating our outline for the enclosure. Now, because these are still shapes and not really sketches, I can select both of them, Shape 2D View and Shape 2D View 001, and use this toolbar icon which says convert bidirectionally between draft and sketch objects. So what it's going to do is convert these shapes into sketches, which is what we are really aiming for. So I click that and I get a sketch object now, and I can now hide the shape view objects. There you go. So I have one sketch now, which is what we want to start off with as the starting point for this this whole project. Any questions up until now? Just unmute and ask, and I'll try and answer them. But I'm going to continue at this pace if everyone's comfortable with that. The next step is to move to part design, because that's where most of the design gets done in FreeCAD. When you run part design for the first time, it asks you to create a body, which you do by clicking on it. Then you go back to your model tree, and you want to now push this sketch inside of this body because that's going to be a starting point. So I can grab the sketch and dump it inside of this body, which means this body now has one sketch within it. If I double click on the sketch, it opens up the sketcher, which allows me to constrain and give dimensions to this whole PCB. At this point, it's best to get rid of the things that we don't need. For example, we don't need the mounting hole positions for all of these components. So we can start block selecting them and deleting them. We don't need these USB holes as well. Get rid of that. Get rid of that. There you go. Get rid of these holes. Get rid of these. We don't need this header or this header. Actually, we don't need the outline of the potentiometer as well. All we need is the screw hole. So let's get rid of all of that stuff. Zoom in, get rid of the excess. There you go. So that's it. We have the four mounting, 1, 2, 3, 4, 5 mounting holes, the outline of the PCB, the circle where the potentiometer screw needs to stick out of, and the three, actually we probably don't need these as well. So that's the bare minimum of what we need to do. If you notice in the solver messages, you'll notice that FreeCAD says this is an unconstrained sketch with X degrees of freedom. Right now it shows 21 on my for my sketch. What it means is that each of these elements you see here doesn't have any dimensioning associated with it. So I can, kind of move it around or change its location, which is not what I want to do. I need to lock down those numbers. So the first step is to start providing dimensions to the sketch so that you will go down from 81 degrees of freedom to 0 degrees of freedom. That's when you have a fully constrained sketch. And that's really the basis of how FreeCAD sketching works. You need constrained sketches in order to be able to create objects. Actually, there's some more stuff I can get rid of here. I don't need all of these arcs to get the center. I just need one of them. So I can delete, I can just retain one of them and get rid of all the others. So in order to get constraints, what I am going to do is add X and Y dimensions for linear items. And if it's an arc, then I'll need a radius or a diameter for it. So those are the dimensions that I'm going to start using now. In the sketcher, there's two essential parts to the whole toolbar that you see. One is a set of constraints that you see here on the left. You can constrain things with relation to each other, such as 2 points or a point in a circle. Or you can make lines horizontal and vertical, or you can make them equal or parallel, perpendicular, tangential, and so on, equal along a center line, for example, and stuff like that. And then there's tools that let you draw things like points, lines, arcs, circles. You can draw splines, or you can draw polylines, rectangles and squares, polygons, stuff like that, and some couple of other options. There's also two things to note over here. When you see a line that is shown yellow like you do now, it's actually a sketch line. But there's also a way to introduce what are known as construction or helper items that are not actually part of the sketch, but can be used for dimensioning or placement purposes. So in our case, all of these items we see here are actually going to be just placeholders for the other things we want to do in the enclosure. So I'm going to select all of them and change them into construction lines. We're using this icon that says toggle between toggle construction mode. So once you do that, you'll notice all of these lines now turn blue, but they're still unconstrained. So we still have to do constraining for them, right? So let's start off with the lines are the easiest. these two horizontal lines need a horizontal constraint. So you can see these two black constraints come up over here. And we've gone down from 54 degrees to 56 to 54 degrees of freedom. Same thing with these two vertical lines. They are vertical, so give them vertical constraint. That makes them, that reduces the number of degrees of freedom. Let me actually finish off the circles first. That'll be the easiest. So let's take this circle, second, and three. These three circles are a common radius or diameter. We can switch to either radius or diameter constraining using this icon. So it helps to just do radius right now. So I'm going to choose radius. And because I've chosen three different circles, it asks me if they all need to have the same radius. I say yes. And it gives me a number, which is what it should be, because this has come from the KiCad sketch. So I just choose OK. And I'm reducing the number of degrees of freedom. So I have these three circle radii fixed. These two also provide a radius constraint and choose the number that it offers, 0.049 inches. So here goes that. We reduced constraints to 47. And then the radius of this circle, which is here, is 0.047 inches. Click OK, that's it. So we have the radiuses of the circles set. Let's set the radii of the corner fillets on the board. So I know that all the four corner fillets are not equal. The two on the left are larger radii than the two on the right. So I'm going to just choose the two left corner radii and choose the radius constraint option, say yes, and it offers a number 0.085 inch, say OK to that. So that's another two constraints set. I repeat this on the left side with the other two corner radii. Select the constraint for radius, say OK, accept the number, and you can see the numbers are different. On the left is 0.075 inch, on the right is 0.085 inch. So those corner radii are not the same. So we have the radius for all the arcs and circles on the board. We can now start giving the XY locations of each of these elements. So that reduces the number of degrees of freedom. This one I know is located on this center line. So I choose those two. I choose the center point of this circle, and I choose this horizontal line, and I choose this tangent option over here, which is, it fixes a point on the line. Actually, let me use this one, the tangent constraint. I need to, yeah, this is the one I should have used, the one that I originally mentioned. Fix a point on this. So this way I can now move the circle in the X direction, but not in the Y, because it's attached to the X axis with the last constraint that we did. That's one more constraint down. The other constraint I need is its distance from the Y axis. So I choose the Y axis and the center of the circle, and choose this toolbar icon that says horizontal distance. So clicking that gives me 0.310. Click OK. So this circle has now got its radius fixed and its XY dimensions, XY coordinates for the center fixed. I can't move it anymore. So this is a fully constrained circle now. I have to start repeating the same for all of the others. Let me add the XY coordinates for the center of this arc that you see here. So I select the center point, select the Y-axis, select the horizontal constraint setting, and say OK. And I select the point again, the horizontal X-axis, and choose the vertical dimension, and I say OK. I start moving things around so it doesn't get confusing. So that's the XY dimensions for this arc. That's the X dimension for this. The Y is actually 0 because it's stuck to this line, so it doesn't have a Y dimension per se. And these arcs. So we're making progress. We are down to 38 degrees of freedom from whatever we started off with. Now, these two circles are spaced equally along the x-axis. So I choose the centers of the two circles and the x-axis and apply the equality constraint, which is these two arrow symbols that you see here. So these buttons, so these circles are now equally spaced along the x-axis. I repeat the same for the other two circles on the other side. Choose their centers, choose the x-axis, and choose equal. So that reduces another constraint. What I need to know is the xy coordinate for the center of this circle, because the other one is a mirror of it, so we just need to choose one of them. So let's do that. Center of the circle, y-axis, choose the horizontal distance and click on OK to the number it says. And then center of the circle, x-axis horizontal, and then choose the vertical constraint, click OK. You get this. So now I have these circles that are.
And
yep, tell me.
There's a pretty good question in the links. Let's see. Andy says you say we need constraints, but they say it works without constraints. Why do you want to go through this whole process of constraining everything when it's already in the right spot?
I want to walk through this whole thing. So I know it works without constraints, and it's kind of tempting to do that. But in the long run, it kind of helps because once you have things fixed like they are now, you know how the dimensions are. If you want to change things, it becomes easier and so on. Because let's say you want to make some changes here and bring it back into KiCad. The KiCad step-up tool workbench lets you do that as well. You can push and pull between KiCad and FreeCAD the edge cuts or the mounting holes and so on. So yes, it works if you don't give constraints. But I like to do it, and I thought it's probably good to show it today. You don't always have to do it, but maybe it's a good way to get people introduced to this whole system of what constraints are and how you work on them. Does that is that satisfactory in terms of an answer? I hope. Okay, so I moved these two circles, and you'll notice that I could move them because there are two center points.
So Anul, just a question. So
yeah,
what are you asking? So basically, what you seem to be saying is that when you are designing a mechanical enclosure, it has to have the dimensions nailed in, right? That is what you seem to say.
That's true. But as Andy said, it's not really essential, but it kind of helps. I mean, and since you're doing this for the first time, I thought it's nice to walk you folks through how dimensioning and constraint works.
Yeah. Yes.
Right? Now, when I constrained this point, I ended up constraining this arc over here, the center point of the arc. But the circles I can still move around, as you can see, right? So one easy way to fix that is to choose the center of the circle, the center of this arc, and make them congruent using this icon, which says coincident constraint. So once you do that, the circle is fixed there. Do that with this second one as well. Make a coincident, and that fixes that. Repeat the same on the other side. Oh, this is already fixed. So for this, I fix the horizontal distance by selecting the center, the vertical axis, choosing this number, saying OK. Let's move the other way. It's vertical distance from center to the horizontal axis is 0.230. OK. There you are. So let's see if, okay, this one is fixed. This one is fixed. all the 5 circles are fixed, and we're down to 26 degrees of freedom. Let's fix the overall width of the PCB. So this endpoint in the vertical line on the left and the endpoint on the vertical line on the right. I select those 2 points, choose the horizontal constraint, and say, okay, this is 2 inches long. Then the left endpoint of the horizontal line at the top, left endpoint of the horizontal line on the right, and choose the vertical constraint. It's 0.6 inches. Say okay. There you go. Right. The next thing is these corner arcs are tangential to these lines, so we need to fix that constraint. I select the line and the arc, and I choose this tangency constraint. So that's 1 for each end of the arc of that. So once and twice. Repeat that one, twice, and rinse and repeat it 4 times for all the 4 corners. So tangency here. I'm going to go a bit quick now because you kind of get the idea of what I'm trying to achieve over here. Quickly move through the constraints. I'm down to 19 constraints now. 18. 17. 16. Okay, these two make them congruent. So I'm down to 15 constraints. If you reach a stage like this and you want to figure out what constraints are still left to be done, click on the hyperlink over here where it says 15 degrees, and you should get green lines of whatever is not yet fixed in terms of dimensions. So this one was shown as green, and if you notice, you can move it vertically in this axis. That's the constraint that's missing. So I'm going to make this endpoint congruent with this arc over here, like so, and repeat it with these 2 points here. Down to 11 degrees of constraints. That's probably do have the same issue here. Yeah. So let me choose these 2 points, make them congruent. Choose these 2 points, make them congruent. Down to 7 degrees of freedom. Let's see which ones are left. I think it's probably these horizontal lines. Yeah. So choose these 2 points, make them congruent. Zoom down here so I can do it. These 2 points, congruent. And probably need to do the same for the one at the top. So fix those 2 and fix these 2. So left with 3 degrees of freedom, which is this arc here. Let's see what's the issue with this. Okay, yeah. This needs to be tangent. So 2 degrees left, which is probably this arc, right? So I can just say this arc is an angle of 90 degrees just for. And okay, it's position with respect to the center point. So I can choose the center point and one end of the arc and say that horizontal distance is 0. So we have a fully constrained sketch now. All the lines, arcs, and sketches are fixed. If the dimensions look a bit crowded, as they do here, you can hide them using the hide command over here. So that shows you just a sketch, and then you can see the dimensions again. So this is what we want to start with as the starting point. Let me go to my original design and show you that the things I will need, and start with, oops, not the pad, but the sketch. So this is the first sketch we are trying to achieve. The green line you see is the outside of the enclosure that we are trying to build. And it's kind of spaced around the existing PCB that we have. So we're going to start with this over here and make a rectangle with rounded edges, which will be the starting point for our enclosure. Now, up until now, it seemed like it was a bit tedious and time consuming to put all of these constraints, but the rest of it becomes much easier once these are all fixed now. So here's the rectangle tool icon. You click once, drag, click a second time, and you get a rectangle. We want rounded edges or fillets on the corners. So I'm going to choose the fillet tool, which is over here. Create a fillet between two lines or at a coincident point. And I choose the horizontal line and the vertical line. It gives me one fillet, and I keep doing it for all the four corners. Vertical line, horizontal line, horizontal line, vertical line, vertical line, and horizontal line. So here I have the sketch ready. And
no, Andy has another question. If you refresh the data from KiCad, will it keep these constraints?
If you move things in FreeCAD with constraints set, then you can get them into KiCad. But I'm not sure I got the question right, though.
Yeah, I think it was the other way around. If you change things in KiCad and import it into FreeCAD.
Okay, so if you do that, it'll overwrite your existing constraints. Although I've never tried that, because once I fix constraints, I don't want to move them around. It's usually the other way around. I would move things in FreeCAD and then import them into KiCad, and not the other way around. Okay, so the other concept here is what's known as getting external references or linkages to external geometries. That's this icon that does that. What this lets us do is use an existing sketch, such as this vertical line or this horizontal line, as a reference to constrain the sketch that we are trying to do. And let me see if I can show that. Let me first set the constraints for this that are apparent. That is the four. I want the four corner fillets to be the same radius. So I'll choose four of them and make the equality constraints, which sets the same radius for them. I haven't set a number to it yet, but I made sure these four are equal in radius. The next thing I want is the length of this line to be the same as the length of this line, right? So I can choose these two and choose that equality constraint. And because this is spaced equally along the y-axis, I can choose these 2 points, choose the vertical axis, and say, make them. So you'll see this matches up, and so does this. The other thing I want to do is repeat that with these vertical lines. So these, okay, now let me not do that, because these lines are not the same length. They are different lengths because these radii are different. Let me just make them equidistant. Oops. Choose this point, make them equidistant along the x-axis. So there's the equality constraint. Same thing for the two on the other side. Equality. So there goes. Sometimes you'll notice your solver gives you messages like redundant constraints. That means you've added a constraint that's really not needed because it is over constraining it. And over here it's showing me constraint 49 is redundant. So I can click, I can, in the constraints box, I can move down to 49 and delete that. All right, the next thing I need is to make sure that the center point of these, the circle and this arc, are coincident. So I'll select those two center points and make them, use that. The easier way is to make this equal to this. There it goes. So now there's just 1 degree of constraint left, and that is the size of this box. It's going to follow the outline of my PCB. I just need to choose how thick I want it to be. So that's this gap between these 2 points, this linear vertical distance. Let's say 0.1 inch is about 3 mm, so 0.2 inches. So that's going to be my the outline of the enclosure that I'm going to build for this device. Actually, 0.1 might be a bit too much. We don't need it to be that thick. So let's go down to constraints, select 0.2 and make it 0.1. 3 mm is plenty thick for 3D printing, so should be okay. Good for this. Here it is. So once you have a fully constrained sketch, your solver says so. It says fully constrained sketch, and you can close this. We now have this sketch, which is surrounding our PCB. And because we want this to be the lower part of the PCB, we are going to extrude it in the negative Z direction. So you click on sketch, and if you go to the task tab, you'll see there's a couple of options here. You can do pads, pockets, holes, and stuff. You click on pad. It's padding in the plus Z direction, so you can choose reversed, and you can give it a number. Now, one easy way to figure out this is to select, let's say, the front view. This icon lets you choose the wireframe mode, or if you click V and then 4, you get wireframe. So this gives you an X-ray view of the whole thing. And this lets you set the height of this object. Let's say we start with 0.3. It's still too tall. We don't need it to be so tall over here. Let's set to 0.2. Less, let's say 0.25. There you go. That's the lead of this potentiometer. So I'm assuming that's how far we want it to be. You choose OK. If you go back to the view flat lines mode, you'll see that you have a solid object, which is what we first made here. This one. So that's the first step of it. The next step we're going to do is apply a thickness to this object, like so. So it kind of becomes a hollowed out enclosure kind of shape. That's a pretty simple step in FreeCAD. You choose the face that you want hollowed out, the top face over here. And in the part design workbench, there is this tool that says make a thick solid. Click that and give it a number, 0.04 inch. So we can make the PCB visible by clicking mouse key, pressing spacebar, and looking at the top view. Go back to task, and we can make the thickness inwards because we've set the outside dimensions of this whole enclosure. And make it 0.05. 0.0. This is very nice. Thickness 0.05. There goes. At this point, we can see that the enclosure is much larger than we really wanted. We can actually make it a little bit smaller. So the earlier object we made, the pad, you can see is hidden. Now, if you click on it once and then press the space bar, it becomes visible. If I click on thickness and press space bar, that becomes visible. So it keeps moving between the two to get rid of the PCB. So that's the thickness, that's the pad. And we want to use reduce this dimension from 0.1 to maybe 0.08. Close that. On thickness, we have a better size for this enclosure now. All right, so that's the next step, which was creating this thickness. Third one is something I'm going to show. I'm trying to show you different functions and features in FreeCAD. So that's the intent of walking slowly through all of this. This third step will allow us to apply this kind of a lip to our enclosure, as you can see here. And we'll have the corresponding mating lip on the upper part of the enclosure. So when you close the two of them, you get a nice seal between the top and the bottom halves of the case, like this. So we're going to have this. There are a couple of different ways of doing this. One way is you can choose this face and click on Create Sketch. And around here, you can build two rectangles with rounded edges. The inside rectangle kind of follows this outline over here. And the outside is, let's say, a certain thickness away from the inner one. And then pad it. But I wanted to show a different technique, which is known as making additive pipes. What an additive pipe requires is a sketch. In this case, when you're looking at it from this end, a rectangle drawn in this plane, which is going to follow the edges along this inside of the case. So you draw one sketch and then you ask FreeCAD to make an additive pipe along this whole edge. And that's an interesting concept to use. So let's do that first. We want to make sure that we are in the body. And get rid of the sketch. Okay. We are in this body and we want to create a sketch. When you do that, FreeCAD needs to know which of the three planes you want to choose to make the sketch. So I choose the YZ plane, click on OK, and I get back into the sketcher mode where I can start drawing things. Let me get back to wireframe, like so. So this is where I want my rectangle to be. That's going to be the lip of the bottom part of the enclosure. So that's going to be a rectangle. Let me choose rectangle and just make a random rectangle over here. And I want this this vertex of the rectangle attached to this corner point over here. So let me just rotate a bit so I can see that edge clearly, which is this edge. And I want to use that as a reference for attaching this sketch, which brings me to use this toolbar icon that says creating links to an external geometry. Click that once, and if I click on this sketch, I get this sketch selected as a reference point. I can then go back to here, zoom in, and you can see this point over here. let me attach this vertex of the rectangle to this reference point using the congruency constraint. So this rectangle is now fixed at that point. I can change its width and its height, but its position is pretty much fixed. So let me set the width to, using the horizontal constraint, and the wall thickness here was 0.08, so half of it is 0.03. I'll give a little bit of leeway for 3D printing, make it 0.03 inches. So that's the width. Maybe I should make it even less, I think. Yeah. That's the width, and the height is actually arbitrary, but we can just make it twice of 0.025, so that's 0.05 inch. That's the height and the width of this rectangle. That's a constraint sketch because it's turned green. The solver says full is constraint. Close it. And let me get back to flat lines view. And you'll notice this little rectangle sketch here that's attached to this edge over here. And now we can start making an additive pipe, which is this icon here under sketch tools as additive pipe. It's also here in the toolbar at the top. So when you click on additive pipe, it has already chosen the object that needs to be piped as sketch 001. That's the one that you already drew. And now it wants you to add edges where you want the sketch to be lofted. So I click on add edge and I choose this one. And you can see this lip has been added over here. And I keep doing that. I click add edge, select it, and I'm sure there is an easy way to do this instead of choosing each edge individually, but I haven't yet figured it out. So if anyone knows, let me know how I can choose all of these edges in one go instead of having to do them individually like this. So keep adding edges, add an edge. I've got one last one remaining to be done. There you go. Close it. So I now have added a lip to this enclosure. That was this step in my original design. The next is to add these supports in the corners for the PCB to rest on. And I've actually created one and then mirrored it on the other side like so. We're going to learn mirroring and how to make pads inside of an existing sketch. So let me hide the PCB. And when you want to draw things, you can either just click on task and say create sketch, in which case it will ask you which plane you want to draw the sketch in, or you can just click an existing face such as this and then say create sketch. Then it knows that the new sketch needs to be attached to this flat surface. So I'm going to use this corner. I'll need a reference edge. So I'm going to choose that using this tool. And this is going to help me to build the corner standoff that I need over here. The next thing I want to introduce you to is this tool called polylines. Polylines lets you create complex shapes that consist of straight lines and arcs. There's a corresponding tool for splines that is more of a free-form drawing kind of a thing. Polylines lets you create more geometrical complex shapes. So we're going to choose the polyline option. And it starts off by drawing a straight line. That's what it does as the first step. And I can continue drawing straight lines, or on the keyboard, if I press the M key, I can cycle through various options, like pressing M once lets me create a 90-degree line corresponding to the earlier line that was already made in either the X direction or the Y direction. If I press M key for the third time, I can draw an arc. And there are several options for drawing arcs. If you keep pressing the M key, it will cycle through all of them. That's an outside arc. The earlier one was an inside arc. an inverted inside arc, and back to a line and so on. So we need to get an outside inside arc like this and click once. So that's the arc. Press M again so I can draw a vertical line like this. Keep going with a horizontal line. Now I need another arc here like so. And then finally I can close this polyline by double clicking on this endpoint. So here's a basic polyline available over here. I want these 2 points to be congruent. So let me start off by doing that. And drag this a bit so things become easier. I want to have these two congruent. I want this arc to be tangential to this line. So let me do that. I want these two lines to be okay. This horizontal line and this vertical line to be equal. This line needs to be tangential to this arc. So tangent constraint. I want these two lines to be equal, like so. And we have these two center points congruent. So there's just 1 degree of freedom left, which is this. Let me bring up the PCB in wireframe mode so I can see what I'm doing here. As you can see, there's a mount hole here for the header pin for the Morse key. So I need to make sure this stays clear of that, like something like so. And at this point, I can now provide an arc constraint for this circle and make it, it says 0.078. Let me make it 0.08. So that's a constrained sketch. Let me close it. Let me get rid of the PCB. Get out of wireframe mode. And you can see the sketch is now attached to this space over here. So I select sketch, I go to task and I say pad it, but this is obviously too tall. So let me look at the front view in wireframe, unhide the PCB so I know what's the height of the PCB, and then give this number over here. Let's see, 0.12 and 1/3 of an inch, leaving some clearance for 3D printing expansion. So that's that. We get out of wireframe again, go to flat lines, hide the Morse key PCB, and that's your support structure for the PCB over here. The next trick to learn is how to mirror objects. So here's the pad you have. If you go to, instead of the part design, if you go to the part workbench, you'll notice this mirror feature. Click that, click OK. I did the wrong thing. Maybe I should use the part design. Sorry for that. Part design. Select this feature, click on, here's the mirror command, create a mirrored feature. Give it, show the axis on which you want it mirrored, like so. Choose the wrong axis. Add, mirror along here. Reference. Yeah, there goes. So this is a mirrored feature. That brings us to this position on the original file that I had thought of. Next one I did was added a support rib here so that the PCB, let me show the, unhide the PCB, so that the PCB gets support like so over here. Do that, I select this face, go to task, click on create sketch, and I drop a rectangle over here. Now, in order to see where this needs to be, I need to unhide the PCB. That's here. Go into wireframe mode so I can see through it. And choose the edges of the enclosure that I'm designing as reference points using the choose reference point icon. Choose this horizontal line and this one. And then I want the width of this rectangle to be the same as the inside width of the enclosure that I'm doing. So I select this point, select the line and make it tangential. And choose the point on the other side, choose the line on the other side, choose tangential. So that fixes the width of this rectangle. Sorry, the length of the rectangle. Here's the width. I set a number like 0.05, no, 0.04. And it now has 1 degree of freedom, which is this movement. So I can, with these holes visible over here, I can choose which is the best location to put this rib. I could put it here. I could have probably squeezed it in here, but not enough space for the solder pad, so we should keep it here. Then choose the corner point, vertical axis, and give it a horizontal constraint. It says 0.717. You get 0.72. So that's a fully constrained sketch now. Close this, hide the PCB. Now go back to flat lines mode so I can see the pad, select the sketch, go to task, and pad this. And same height as the other two corner pieces that we created. Let's look at wireframe. There you go. There we are. So that's the support for the for one side of the PCB. Get out of wireframe into flat lines. Hide this. So that was this part of the design. Next one was to make these semicircular extensions on the top lip of the piece of the enclosure so that it kind of locks the PCB in place. Let me show the PCB, then the side view. So between this bottom support and this semicircular tab over here, you can push fit the PCB and it kind of snaps into place, like so. So we do that by choosing the top face, and I want to draw this on this particular face. Let me show you the 3D view. So I need those extensions made on this face of the enclosure. So I choose that, go to task. I didn't finish the earlier one, which was sketch, task, pad, 0.13. That's finished. So I now choose this top face. Here, go to task, create a sketch, and I'm going to create two of them because they are not kind of equally spaced along the axis. They're kind of offset from the center because these tabs need to be placed at locations where there are no interference from the components on the PCB. So you need to be able to move them around if needed. I'm going to draw two semicircular supports here and then mirror them on the other side because at least along the horizontal axis they are mirrored, but they aren't mirrored along the vertical y-axis. So I'm going to try and make the polyline option, zoom in, draw a horizontal line like so. Using the M key, I can get to the arcs and create an arc. I want to get rid of this perpendicular constraint because I'll show you in a bit why I'm doing that. And like so. I want to pull the center point away. So these two end of the arc and end of the line are congruent, and the other side as well. There you go. So I now have this arc which is independent of the position of the line. Let me set a horizontal dimension for the line, or choose the line, choose the horizontal constraint, make it 0.15. Then I need to select an external reference where I can place this object. So I choose this. I choose this point and make it tangential to this line by using this fixed point to an object. So that's one thing done. Next is to make this, fix this radius. We don't want it too large because then you probably can't push the PCB inside. Let me unhide the PCB so we know how much we need to do it. Here's the PCB, and we put it in wireframe mode so we can see it. So here's the edge of the PCB. We don't want it too small so the PCB doesn't latch, and we don't want it too big so that it breaks the tab. So maybe this is something that you probably either iterate over a test after printing it once, or just enter some number and see if it works. So give this a radius of, let's say, 0.08. Looks okay. And then I need to fix this from this vertical line. Let me unhide the components so that I know which ones are going to interfere, which ones are not going to interfere. So here goes. Here's the component shown. So we want to scooch this so it comes here, so there's enough space for it. And choose this. Set a horizontal constraint, 0.3 inches. So in order to speed things up, I'm not going to draw the second one here. All I'm going to do is close this and add this in the reversed direction. If you notice, if it is not reversed, it breaks the whole geometry and breaks everything. But yeah, so it needs to be reversed, and this one, give it a number. Where's it gone? Here it is. Close this. Add it. Reversed. 0.5. Let's see if that's enough. Looking at the front view, turn on the wireframe mode. And it's kind of touching the PCB, so reduce this 0.05 to 0.04. There you go. So now there is enough clearance here between the PCB and this notch. Get out of wireframe mode. And here it is. So here's the tab that holds this PCB in place. I can select that and using the mirror command again along the, I can put it along the x-axis or the y-axis. Let me do this so I get this one. Select the reference, this one. Okay. There you go. So here are these two pads that kind of hold together. If we mirror it once more, we can have another two over here like we did in the original area. But I guess you get the concept. The next thing was to, let me hide this, was to make these pocket holes over here. So pockets are like extrudes, but negative. It works the same way. You create a sketch on a face and then make a pocket. So let's choose this face, go to task, create a sketch, click on the circle tool and make one circle and a second circle. We choose both the circles and make them equal in diameter. We also choose the center points and make them equidistant from the horizontal x-axis. We choose their radius using this and make them 0.04, probably 0.05. Now we need to locate these in at the center of where the mount holes for the PCB are. So let me unhide the PCB, put it in wireframe mode, and choose an external reference where I can place the center point of these circles. So using external references, I choose this. I choose move it so I get to see it, and then get this reference. This. Put this circle over here. So it seems like it doesn't match up. Let's see where we get a mistake. Control C. Okay, hide the original. Yes, I made a mistake in choosing the center point so that it matches with the PCB. But for the moment, let me just place it here. I know there's an error, but we'll try and fix it later once we get to it. Just make the size bigger. 0.06. Then close the task. Write the stuff you don't need. PCB. Select the sketch. Go to task. Create a pocket. That the pocket option allows you a couple of options. You can give a dimension through which it needs to pocket. So if you want a blind hole, you can give a certain number. If you want it pocketed through everything it encounters through all, you can make it pocket until the first face it encounters or up to a particular face, or you can give 2 dimensions for pocket. In this case, we can just choose through all, click OK, get out of wireframe mode. Oops, I still in wireframe. And you have these mount holes over here, which brings us to this position in the original diagram, which goes across this stuff. Yeah. The next step I did was make pockets on the underside for the screw heads. So that's again pretty easy. You flip this over, choose this face, go on task, create a sketch, make 2 holes, choose both of their circumferences and make them equal, choose their center points, and make them equidistant along the x-axis. Give them a radius of, not sure what's the cheese head diameter for a 2.5 mm screw, but let's say 0.2 inches. Oh no, diameter, so this needs to be the radius, 0.11. So we have most of the constraints except the position. For that, we reference it to this circle using this tool. Then choose the center point, the second center point, make them congruent, and you have a constraint circle. We close this and we get into wireframe mode, look at the front view, and you can pocket that sketch to a distance of, say, 0.2 inches, like so. That gives me, oops, not shaded, flat lines. These pockets over here. The other thing I realized was when I was doing this, let me unhide the PCB. Here's the other thing, when wireframe is too confusing and flat lines is like you can't see through, what you can do is click a body, context click, and click on appearance, and you can now give it, let's say, a certain material property like brass, aluminum. In this case, let me just choose ruby, for example, and you can give it a transparency. Set 50, close it. So you have this colored object with 50% transparency. This makes visibility better, like when you're trying to observe things like this. So that's the transparency setting. The thing that I realized when we made the thickness to the solid object was that the bottom isn't thick enough to make a proper counter bow for the screw of the head. So if required, we can later on extend the bottom face so that it becomes thicker than the side wall thicknesses. And with that, it kind of covers the head of the screws. But right now, let's not do that and see how we can quickly get this thing done. So we made these pockets at the bottom. What's the next step was we made a pocket for the USB connector, and later on a pocket for the pin header from where the Morse keys are connected. So that's at the 2 short edges of the enclosure on each side. The unhide the parts now because that's going to be useful. We need this header, and we need the USB. So we are going to make these two cutouts on this board over here. So we choose this pocket, choose this face, go to task, click on create a sketch. So I can now see the USB connector, which makes it easy to draw a rectangle like so. For the cutout, this will become a pocket. The rectangle is evenly spread along the vertical y-axis. So I choose the two endpoints, vertical y-axis, and make it equal. Let me choose